Welcome to problem set 5. Let's talk a bit about approximating vertex cover. Suppose someone comes up to you and tells you that they've devised a really clever algorithm for approximating vertex cover. Let's call it Clever VC. Now, this is so clever that they don't actually want to show you the source code. They want to keep it secret, so you can't see that. And they don't even return the list of vertices that are in the cover. They just tell you the size of the cover. So how would you go about figuring out the performance of this and how it works? In order to test the performance of Clever VC, how about we test it against 4 fairly large graphs of 10,000, 20,000, 30,000, and 40,000 vertices, and let's compare that against a factor 2 approximation algorithm that we have. See what the size that both come up with are. So you can see that the size of the minimum vertex cover for Clever VC is always smaller than our factor 2 approximation, sometimes by not very much. For example, in this run, 233 versus 234. Not much of a difference. In other cases, it's a rather large difference, like 295 versus 600 in the 30,000 vertice graph. Now, based on this table, there are a number of things that we can say about Clever VC. And these are the questions that I'd like you to answer for me, the statements that we can definitely say about Clever VC. And if you need to refer back to the table, then we'll have that below in the instructor comments. Can we say that given any graph, Clever VC will outperform the 2 approximation algorithm, since in the graphs that we gave it, it most certainly did outperform our 2 approximation algorithm. Now, can we also say that Clever VC is a factor 1.75 approximation algorithm? Or finally, could we actually say that Clever VC is not a correct algorithm? And check true or false for all 3 of these.